Let's practice a couple of examples to do electron configuration. So we are going to start with the rules of electron configuration. There are 3 rules we need to follow, proposed by Aufbau, Pauli and Hund's rules. So we are going to, as we practice, we'll be applying all these rules. So first example is hydrogen with atomic number 1. We are going to start filling out these atomic orbitals. So this is an atomic orbital diagram. Here you see these orbitals are arranged in the order of increasing energy. So the first one here, the 1s, it has the least energy. As we go up the series, then the energy of these orbitals will continue to increase. What comes after 1s? These squares over here represent the orbitals, and 1s is the name of the orbital. Now we know that there are orbitals are the locations where there's probability of electron exist, and they are the areas outside the nucleus, the location outside the nucleus where electrons can be found in these orbitals. And there are different types of orbitals, 1s, 2s, 2p. So they are arranged in the order of increasing energy according to Aufbau. We start filling in the electrons in these orbitals from the lowest energy orbital first. Hydrogen has atomic number 1, so which means that the number of electron is also 1. We are just going to fill out 1 electron in these orbitals. So, and that will be represented by an arrow, since 1 arrow represents 1 electron. So what's the electron configuration for hydrogen? 1s1. We are going to take next example, lithium with atomic number 3, which means we need to fill out 3 electrons in these orbitals. So we have already 1. We are going to continue with that. So according to Pauli, we can only fill out 2 electrons in each orbital. No more than 2, and that 2 with opposite spins. And the 3rd electron goes here. So what's the electron configuration for lithium? It would be 1s2. You can see there are 2 electrons here, one facing upward, one facing downward. These are the spins of electron, clockwise and anti-clockwise. And then the 3rd electron goes in the 2s orbital, so that will be 2s1. And also we can check by adding these numbers on the top, that should be equal to the atomic number. So it means you're heading in the right direction. Let's take another example, which is sodium equal to 11. So we are not going to be filling out, we are just going to proceed with the 3 electrons. We need to fill out 11. So we have already filled out 3 electrons, and then we can, as Pauli said, we can fill in 2 electrons in each orbital facing in opposite directions. One facing upward, one facing downward. So in total, we have already filled out 4 electrons. Now we look at 2p orbital. Now you see there are 3 sections, like it's divided. There are 3 orbitals, there are 3 types of 2p orbitals, 2px, 2py and 2pz. Now according to Hund's, we cannot start pairing them up unless we fill out 1 electron in each of these. So as you're filling it out, make sure you're counting it in your head. It shall not exceed the atomic number 11. So how many you have filled out so far? 1, 2, 3, 4, 5, 6, 7. Now that you have equally filled out each type of 2p orbital, we can start pairing them up. So it would be 8, 9, 10. So we need to fill out 1 more that goes in 3s orbital, which will face upward. Now we need to stop here because atomic number for sodium is 11. So let's write down the electron configuration for sodium. That's going to be 1s2, 2s2, 2p. There are in total 1, 2, 3, 4, 5, 6 electrons. And then we have 3s, only 1 electron. So again, we can add those numbers on the top and see if that equals